In this video, we're gonna code a wrapped Ether token in Solidity. And before we continue, make sure you join the Facebook group of EatTheBlocks, where you can ask all the questions you want about blockchain development and how to find your first blockchain job. So what is a wrapped Ether token? So on the blockchain, there are smart contracts that are called decentralized exchanges. They allow to trade ERC20 token in a decentralized way without any centralized party. However, one problem these decentralized exchanges can encounter is that they have to manipulate both ERC20 token and Ether and ERC20 token have APIs that are completely different, and so that can introduce some complexity in the code of these decentralized exchanges. Could we manipulate Ether with the same API as for ERC20 token? Well, yes, we can, with what we call wrapped Ether. So basically, wrapped Ether token are ERC20 token that have some Ether collateral inside. So when you want to create a new wrapped Ether token, you have to provide some Ether to the smart contract of the wrapped Ether token. And if you want to get this Ether collateral back, you have to give back your wrapped Ether token. So let's see how we can code a wrapped Ether token in Solidity. So here I am in Remix, and we're gonna create our smart contract for our wrapped Ether token. We're gonna call this WETH. Okay, so we're gonna start with a pragma statement. And after that, we're gonna import the ERC20 implementation of OpenZeppelin. So this is the GitHub repo of OpenZeppelin. If you don't know what is OpenZeppelin, check out this series on OpenZeppelin on my channel. So I'm gonna scroll down, I'm gonna go inside contracts, inside token, ERC20, and ERC20.sol, and then I'm going to copy the URL and then back to Remix, then import, and then we can paste this URL, terminate by semicolon. Alright, so now we can use the ERC20 token of OpenZeppelin in our smart contract. So we're gonna call our contract WETH. We make it inherit from ERC20 because itself, this is an ERC20 token. And after that, we're gonna define its constructor, so it doesn't have any argument. Then we're gonna instantiate the constructor of ERC20. So first, this is the name. So we're gonna call this wrapped Ether. And after, this is the symbol, so WETH. And we make this public, no implementation for the body. And after that, we need to define two functions. The mint function to create a new wrapped Ether token, and the burn function to when you want to do the reverse operation. So first, we're going to create the mint function. Doesn't take any argument, and it's payable because we need to be able to send some Ether to this smart contract, to this function. And then we're gonna call _mint, which is provided by the ERC20 implementation of OpenZeppelin. And then we need to give it the recipient. So the recipient is the caller, the sender of this transaction, MSG sender. And then what's the quantity of token that we need to create? Well, we're gonna make it simple. And if you send one way of Ether, then you're gonna get one token. And if you want, you can have another rule, like if you have a different price for your token, you can multiply by 2, by 3, whatever you want. But you know what, let's just keep it simple. So with this, when someone wants to create a new wrapped Ether, then he calls this main function. It provides some Ether. This Ether is locked inside the smart contract of wrapped ETH. And then in exchange, this address gets its wrapped Ether token. And so after, with this wrapped Ether token, you can do whatever you want. You can transfer it to someone else, or you can keep it forever. And maybe that at some point you have your wrapped Ether token, and you say, okay, well that's cool, but now I want to get my Ether back. So you can do this by calling the burn function, and you need to specify what's the amount that you want to get back, external. And so we're gonna send you this amount of Ether, and in exchange we're gonna also burn your token. So for the address, this is the color of this function. And for the amount, well, this is the amount that you specify. And you might say, okay, well, this doesn't seem very safe to me because I can call this burn function with whatever amount I want and burn tokens that don't belong to me and get sent a lot of ether, so I can steal some ether from this smart contract. Well, actually, no, because inside the implementation of the burn function here is going to check that you have enough token, otherwise you're going to burn other people's token. So if you try to call this function with an amount that is too big, then underscore burn is going to throw an error and the whole transaction is going to be canceled. So this is a safe implementation. And actually, if you want, you can even make your wrap ether even more interesting and create what is called collateral backed token. And instead of having your token backed by ether, you can also sort of create a meta token that is backed by multiple other tokens. So that would mean that here in the min function, then you will call the transfer from function of other token. So you will transfer from the sender of the transaction and to the address of this smart contract. And here in the burn function, then you will do the other operation. So you will transfer to the sender. And yeah, that's how you can do it with ERC20 token as well. But for example, we just do it with Ether. And if you want to see many other cool tricks with Solidity smart contract, I have another series full of them. So I'll see you there.